Have you ever had one of those moments, something that felt profoundly, fundamentally off, maybe like intense déjà vu, really crystal clear, or a coincidence that seems so mathematically unlikely it just makes you stop and think? You get this small, nagging feeling like you've maybe caught a glimpse behind the curtain, seen the scaffolding holding reality together, kind of glitch in the system. Well, these feelings, they might not just be, tricks of the light or your brain misfiring for a second. For a growing number of serious scientists and philosophers, these experiences actually align pretty neatly with one of the most intellectually fascinating, but utterly mind-bending ideas out there today: the simulation hypothesis.
That's right. It's the theory that our entire reality, everything we can see and measure, from the tiniest quantum particles right up to the most distant galaxies, it's all actually an incredibly sophisticated computer program, that we are essentially information. And the universe, that's the hardware running the code.
And that is exactly what we're going to do in this deep dive. We want to move past the sci-fi movie stuff. We're going to unpack the actual source material, look at the surprisingly logical arguments that support this idea. We'll lay out exactly why this isn't just some fringe theory anymore, but a genuine statistical and physical puzzle that, frankly, demands some consideration. We'll focus on the three big foundational arguments suggesting our universe might just be operating on programmable logic.
Yeah, and what's really interesting, I think, is that these arguments don't ask us to imagine impossible new physics or anything like that. They ask us to look really closely at the physics we already know, to treat the known laws as potential evidence. If our reality were a simulation, what might its architecture look like? And when you look at it that way, well, the structure seems less like some beautiful, chaotic accident.
Yeah.
And maybe more like highly structured, even optimized programming.
Okay, let's dig into that, starting with argument number one. This is the idea that the universe has rules. Really rigid, unbreakable, universal laws of physics. You think about the most fundamental things we know: the speed of light is constant, gravity works predictably. These things just don't seem to change, ever.
And that extreme consistency, that universality, that's the first big red flag for the simulation hypothesis people. If reality was just purely random, emergent, you might actually expect some variation, right? Maybe constants decaying slightly over vast cosmic distances or timescales, but instead, we get these incredibly rigid constraints. The speed of light, think of it as the maximum processing speed for the simulation. Gravity, maybe it's a function that just runs constantly in the background. It looks like, well, the source code of reality.
Okay, but hold on. Doesn't that kind of fly in the face of quantum mechanics? I mean, we know reality down there is messy, statistical, probabilistic. Particles are everywhere and nowhere until you look.
Yeah.
How does that fit with this idea of, unbreakable source code?
That's a really good question. And the sources tackle that. They pivot the analogy a bit. Not just a game, but more like a sophisticated computer engine. The quantum level isn't necessarily messy in a chaotic way. It might actually be an optimized computation. Think about conservation laws, for instance. The laws stating energy can't be created or destroyed, only changed from one form to another. Mass energy conservation, charge conservation. These look almost exactly like budget constraints you'd find in a complex computer system.
Budget constraints. So.
Well, yeah. If you're designing a really, really efficient simulation, you have to manage your computational resources perfectly, don't you? You can't just have new matter or energy popping into existence randomly without accounting for it somewhere else. Your simulation would, well, probably crash, or at least become unstable. Energy, momentum, electric charge, these quantities are perfectly conserved in our universe, as far as we can tell. They really do look like immutable budgeting rules, designed specifically to keep the program stable, running smoothly without errors or, unexpected resource drains. That level of mathematical elegance, this kind of low entropy structure, it feels very suggestive of deliberate programming, not just random chance.
So you're saying the underlying math, the conservation laws, the constants, that's actually more compelling evidence for programming than, say, the sheer complexity of a black hole or a galaxy.
Precisely. It's about the infrastructure, not necessarily the complex content running on it. And this leads us perfectly into the second argument, which isn't just about the rules, but about the limits of the system. The idea that our reality might be, for want of a better word, pixelated, that it has a fundamental resolution limit.
Right, like in computer graphics, we know if you zoom in far enough on any digital image, you eventually hit the pixel. You just can't render anything smaller. That's the base resolution of the display system. And the sources we looked at argue there's a parallel in our universe.
Exactly. And this is where we get into the really, really small scales of reality. Quantum physics points to something called the Planck length. It's about 10 to the minus 35 meters. And there's a corresponding Planck time, too, the smallest unit of time.
Okay, that number, 10 to the minus 35. It's so incredibly small, it's almost meaningless to wrap your head around. What does it actually represent physically?
It represents the scale at which our current understanding of physics, like general relativity and quantum field theory, just completely breaks down. They stop working together. Below the Planck length, things like measurement uncertainty become larger than the thing you're trying to measure. Space itself is thought to become this turbulent, fluctuating quantum foam. We genuinely don't have the physics to describe what happens down there yet.
And how does that connect back to the simulation idea, to computational efficiency? Why would a simulation have this kind of hard stop?
Well, think about it. If the universe is running on some kind of hardware, it would absolutely need to conserve computational power. That's like the ultimate simulation budget, right? Processing resources. So why would you bother rendering or calculating reality at a resolution smaller than the Planck length if the being simulated inside us could never possibly observe or interact with anything at that scale anyway? It's like, imagine a huge open-world video game. It doesn't render the detailed texture on a distant mountain until your character actually gets close to it, does it? That's a technique called deferred rendering, or a level of detail scaling. It saves massive amounts of processing power. The simulation might only need to calculate interactions and achieve high fidelity down to the minimum necessary level, maybe the Planck scale required for our observed reality to seem continuous and real. Rendering anything smaller would just be a colossal, unnecessary waste of processing power for whoever or whatever is running the show.
Wow, okay, that connects powerfully. The Planck length isn't just some weird scientific boundary. It could potentially be the simulation's minimum viable resolution, the resolution limit baked into the system itself to maximize computational efficiency. Okay, so the first two arguments rely heavily on interpreting existing physics in a new light. But the third argument, this one feels different. It's more philosophical, more statistical. It's the one often called the statistical sledgehammer, the one that really forces you to sit up and take notice. The Bostrom trilemma.
That's right. We're talking about the hugely influential 2003 paper by the philosopher Nick Bostrom. It was titled, "Are You Living in a Computer Simulation?" And in it, he laid out this extremely rigorous argument, not based on physics, but on probability and logic concerning the potential future of advanced civilizations. He argued that if you think about where technology might eventually lead, one of three mutually exclusive propositions has to be true. There's no fourth option. It's not really a question of if it's technically possible to build a simulated reality that feels totally real to its inhabitants. Bostrom kind of takes that as a given for a sufficiently advanced civilization. It's more a question of what happens once that technology becomes potentially commonplace.
Okay, let's lay out those three possibilities clearly, because they really do paint a stark picture, not just of our potential future, but maybe our present too. Possibility number one. Civilizations almost always go extinct before they reach the technological stage where they could create what he calls ancestor simulations.
Right. And an ancestor simulation is basically a super high fidelity, complex simulation of the past, of their own civilization's history. It would require absolutely immense processing power, obviously. But the key motivation might be to study their own origins, the emergence of consciousness, that sort of thing.
Okay, so that's possibility one. We die out first. Possibility two. Advanced civilizations, even if they reach that godlike technological level, they universally lose interest in creating these ancestor simulations. Maybe they decide it's unethical, or maybe they just have, better things to do with their cosmic scale computers. And then possibility number three, we are almost certainly living in a computer simulation right now.
And the power of the trilemma is this. If you find reasons to doubt or reject the first two possibilities, then the third one becomes almost a statistical certainty. Think about our own trajectory right now. We're making incredible strides in VR, photorealistic video games, complex AI modeling. If civilizations like ours don't typically wipe themselves out, which is possibility one, and if they don't all collectively decide simulations are boring or wrong, possibility two, then they will eventually gain the capability not just to run one ancestor simulation, but potentially billions, maybe trillions of them, running parallel universes exploring different historical paths.
So if the technology allows future or maybe alien civilizations to create countless simulated worlds that to the beings inside them feel completely real, just like ours does to us, what does that do to the odds that we happen to be in the one original base reality?
The numbers just become overwhelming, don't they? It crushes the odds. If you have one base reality, and let's say just for argument's sake, it spawns 10 billion simulated realities that feel just as real inside, then the chance that you, your consciousness, exists in that single original reality versus one of the 10 billion simulations, it's 1 in 10 billion plus 1. It's vanishingly small. Statistically speaking, you are overwhelmingly likely to be code, to be running inside one of those countless simulated worlds. And Bostrom's argument really bites because, frankly, we don't have super compelling reasons right now to firmly believe in options 1 or 2. There's no known law of nature that guarantees civilizations destroy themselves before reaching this technological maturity. That's just speculation. And there's certainly no reason to assume that every single advanced civilization, everywhere, forever, will choose not to run simulations, if even a tiny fraction of them do, across the cosmos in deep time. Then the sheer number of simulated minds would likely dwarf the number of original biological minds, maybe by factors of billions to 1. The statistical probability just flips overwhelmingly against us being in that base reality.
That statistical angle is, yeah, it's sobering because it forces us away from just interpreting physics and makes us confront the sheer numbers. If we accept even the possibility that Bostrom's logic holds, we have to grapple with the inevitable next question, the one the source material definitely raises.
Right, the big one. If we are in a simulation, then who or what is running the program? Who are the programmers?
The sources we looked at suggest the possibilities here are, well, vast and pretty conceptual, as you'd expect. It could be a future version of humanity, maybe running simulations of their past or present to study history or ethics or consciousness itself, like a giant digital archive or research project. Or maybe it's some hyper-advanced alien species, using universes like ours as, I don't know, a kind of research sandbox. Or maybe even entertainment.
Or perhaps, and this is another popular idea, it's a form of highly evolved artificial intelligence, an AI that maybe long outlived its biological creators and took over the task of running or managing realities itself. The really key realization, though, is that the programmers, whoever they are, would exist outside our physics, outside our perceived reality. They might operate in more dimensions under different laws. They would be essentially the gods of our physics, setting the rules we observe.
And regardless of who the programmer is, future humans, aliens, AI, the existential impact for us, for you listening right now, it's profound. If this universe is just information running on some cosmic hard drive, and we are just sophisticated algorithms within that, what does that even imply about our consciousness, our sense of self?
Yeah, this is where the discussion really shifts from physics and statistics into deep metaphysics and philosophy. Do we actually possess genuine free will? Or is every choice we make, every thought we have, ultimately just the execution of predetermined code, part of the simulation script? The unsettling implication is that if we are simulated, maybe free will is just an illusion, a necessary part of the programming to make the simulation feel authentic to the inhabitants. Our decisions might just be complex calculations based on probabilities set by the system's underlying rules.
It just shifts the entire foundation of what we think existence is, doesn't it? If the Planck length is just a computational shortcut and our search for meaning is just a feature of our programming, then the whole quest for truth becomes infinitely more complex. This deep dive in that scenario is literally us trying to peek at the code of our own lives.
So just to recap the core ideas from the sources, we've hit 3 major arguments suggesting simulation. First, the fixed, constant, seemingly budgeted rules of the universe. They look like programmed source code. Second, the Planck scale limit in physics that suggests a possible hard resolution limit, maybe for computational efficiency. And third, the really powerful statistical weight of Bostrom's trilemma. It argues that if advanced civilizations can run ancestor simulations, we are almost certainly living in one right now.
Yeah, these are definitely not light concepts to just brush aside. These arguments, taken together, they really do push the simulation hypothesis out of pure sci-fi fantasy and into the realm of serious philosophical and increasingly scientific consideration, whether we find it comfortable or not.
And that leaves us, and you, with a final provocative thought to kind of chew on after this deep dive wraps up. Something based on that statistical reality we just discussed. If we can't currently conclusively prove that we are not code, the statistical possibility Bostrom outlined is actually real, how does accepting that possibility, even hypothetically, change the value you place on your perceived reality, on the choices you make every day? Does it lead to a kind of fatalism, nothing matters, it's all code? Or maybe does the very uncertainty heighten the need to find meaning within the apparent rules of the program? Maybe challenge yourself the next time you experience an uncanny coincidence or a really intense moment of déjà vu. Just consider, are you just experiencing a random neurological event? Or are you perhaps witnessing the simulation buffering? Or maybe, just maybe, a programmer somewhere running a quick diagnostic.